Okay, so we're going to have a look at the dot cross diagrams for GCSE ionic bonding. So we'll have a quick, just a quick refresh over ionic bonding before we go ahead. So just got to remember what ionic bonding is. It's what happens when we bond a metal with a non-metal. So the first thing that I always tell you to do when you get a question about bonding is go and look at your periodic table, okay, and go and find if the two things you're being asked to bond together are a metal and a non-metal, so one on the left and one on the right of your staircase, and if that's the case, then you've got to do ionic bonding. Now, both things ionic bond for the same reason, okay, whether it be a metal or a non-metal. They want to gain a full outer shell of electrons. Now, for everything apart from hydrogen, that means that they want to get 8 electrons into their outer shell. Okay, and you'll see that called the octet rule. The octet rule meaning that exactly they want to get 8 electrons into their outer shell. But they do this different ways. Okay, in metals, the electrons are lost, and in non-metals, those electrons that have been lost from the metal are gained. So here we get electrons gained. Now, how does that change? Well, if you remember when you did atomic structure, everything in the periodic table has the same number of protons and electrons, in other words, the same number of positive charges and negative charges. So everything to begin with in the periodic table is neutral. So if something loses electrons, which are negative, and it was originally neutral, well then it becomes a positive particle. And that becomes what's called a positive ion, hence the term ionic bonding. Electrons from the metal are gained by the non-metal, and that becomes, unsurprisingly, a negative ion. Okay, the common name that you need to be aware of for a positive ion is a cation, and for a negative ion, another term that you need to be aware of is anion. Okay, so maybe you can now start to see what the actual attraction is. You end up with a metal, which is positive ion. Okay, that can be positive 1, 2, 3. Okay, and you end up with a non-metal, which is a negative ion. And of course, what do positives and negatives do to each other? Well, they attract each other. And that then is essentially our ionic bond that we have between a metal and a non-metal. So whereas up here, the metal and the non-metal weren't attracted to each other, now they are actually bonded to each other, okay, and they form various different compounds that you'll meet as you go through your GCSE course. Okay, so we're going to have a look at a few examples of how we would actually do this. Okay, and these are, so what you might want to do here, guys, is perhaps whenever I do a couple, just have a look, make sure you can do them. And then perhaps you can pause the video whenever I put one up on the screen and do it, and then hit play again and check that what you did is okay. Right, so let's take a really simple one. Let's take the bonding between lithium metal and let's take that and fluorine non-metal. Okay. So I already told you the sort of metal and non-metal, but always get into the sort of the way of going and finding them in the periodic table. So lithium is there, fluorine is there, so of course they're metal and non-metal. Right, first thing that you do here is you work out the electron arrangement of both of these. So lithium has an atomic number of 3, so it has an electron arrangement of 2, 1. Fluorine has atomic number of 9, so it has electron arrangement of 2, 7. The next thing that you want to do then is draw them out, but draw out only the outer shell electrons only. That's generally what you're expected to do, unless it does ask you to draw all the electrons, in which case you would do that. But we'll just draw out, and we'll make the lithium outer one a cross, and we'll make the fluorine dots. So remember I said earlier that the metal will lose the electron. So we show our examiner that we understand that's what happens. Okay, by our arrow, we just put the arrangements underneath, and then we draw what is our new arrangements. So our lithium, this particular shell here now is empty, so we just go lithium, and then a 2 underneath it to show that this 1 electron has now gone, and we do our fluorine, and we do our 7 electrons that the fluorine had, and it has taken 1 from the lithium, so we draw that as a cross. And then we've got to get our charges right. Sorry, we've got to put our new electron arrangement below the fluorine. We can see both have full outer shells now. Okay. Now what we do is we've got to get our charges correct on both of these. So remember, everything starts off neutral. So here lithium had 3 protons and 3 electrons. The fluorine had 9 protons and it had 9 negatives, 9 electrons. Over here the lithium still has 3 protons. Protons are not lost again, but it only has 2 electrons, so 2 negatives. So overall it's got 1 more positive charge and it has negatives. Okay, so therefore it has got a positive charge of 1. My fluorine over here, it still of course has its 9 protons, but it's gained another electron, so it's gone up to 10 electrons. So it's got an additional negative charge, so it's -1. Okay, and that's how you do it for example, lithium fluoride. That's pretty much the simplest one that there is. So, okay, I will do another one similar to this. So perhaps you might want to, as I said, clear or pause the camera or pause the video and do it. Right, so I'll do potassium and chlorine. So we do exactly the same again. We go and we find the arrangement. Potassium is 19, chlorine has atomic number 17. So 287. We go down and we do our outer electron only around the potassium and our chlorine. Okay. Just pop in those. I like to, it's maybe a bit overkill, but better safe than sorry, I think. Okay, showing that the metal has lost the electron and the non-metal has gained that electron. So my potassium now I put in square brackets. On my chlorine, I put my 7 dots in. I'm showing my 1 electron has come from the potassium. This is now 288. It's lost that 1 electron there. And the chlorine is of course now 288 also. It's called a chloride ion. Over here we started off with 19 positives and 19 negatives, protons and electrons. Here we started off with 17 positives, 17 electrons, 17 negatives. We've still got the same number of protons, they never change in bonding. And here we've got 18 negatives. So again we've 1 positive charge in this. Here we've now gained an electron, so we've got 18 negative ones. And there we go. That's the bonding in potassium chloride. Okay, let's up the ante a little bit. Let's go to magnesium oxide. If you feel confident, maybe you could go and do this. Okay, or perhaps you might want to just pause this and watch. This is slightly different. So, atomic numbers 12 and 8, electron arrangements 282, 26. Let's do our dot cross diagrams. Let's put our 6 dots around our non-metal. Again, we would go to the periodic table and check the metals and non-metals, but I'm just doing metals and non-metals here. So, okay, remember the metal loses, so it loses 1 there. Remember, oxygen is going to need to get 2 electrons to get a full outer shell. So I've got to take 1 from the magnesium there, and then I've got to take the other 1 from the magnesium there. Okay, and then we go over. So everything has a full outer shell now, so I'm happy to move on. So we do my dot cross diagram, my 6 original oxygen electrons, and my magnesium has donated those 2 crosses. My magnesium is now 28, and my oxygen is also 28. So remember, my magnesium started off with 12 protons and 12 electrons, so neutral charge. My oxygen started off with 8 protons and 8 electrons, so again neutral charge. My magnesium has lost 2 electrons here, so again 12 protons to begin with and 10, so it's overall 2 plus, so I put my 2 plus up there. My oxygen still has my 8 protons, but it's gained 2 electrons, so it's got 2 negative. So its total charge up there is 2 negative. And that's how you do it for magnesium oxide. Okay. So again, I'll do a similar one to magnesium oxide. I'll do calcium and sulfur. So again, you might want to pause the video and I'll just do this. You can come back to it. So sulfur is 286. Calcium down there, 2 outer shell electrons. Sulfur here, 6 outer shell electrons. So we have 2, 8, 8, 2, and we have 2, 8, 6. Okay, my calcium is the metal and loses the electrons. Sulfur needs 2 electrons, so it needs plus 2e minus in here. Okay. So calcium has a full outer shell, it's lost, it's 2, and sulfur's full outer shell, it's gained, it's 2. So we go calcium over here, sulfur here, put my 6 original sulfur electrons into my 2 crosses. Calcium has lost 2 electrons, okay, so it's 2 plus, and sulfur has gained those 2 electrons, and it's 2 minus. Well, this is the last time I'll do the sort of the plus and minus. So this was originally 20 protons and 20 electrons, so it was neutral. Over here it was 16 protons and 16 electrons, so again neutral to begin with. Okay, still has 20 protons in calcium, but it has lost 2 electrons, so it's overall, that's where I get my 2 plus charge from. Okay, sulfur is 16 protons still, but it's gained 2 electrons, so it's got an overall charge of 2 minus. Okay, so hopefully that was pretty straightforward for you. We'll do another couple. Okay, so let's do this time we'll do lithium. Okay, this time with oxygen. Alright, so there's another little twist to this one. So again, lithium 3 and 8, so that's 2, 1 and 2, 6. So I put my lithium outer electron there and my oxygen 6 there. Okay, so my lithium is the metal, so it loses. Now you might notice here now that the oxygen has gone from 2,6 to 2,7, but it needs 2 electrons in order to get a full outer shell. We can't dip into the next shell of lithium, that's not allowed. Okay, far too much energy involved in that. So how are we going to solve this problem? Well, we can use as many lithiums as we want, but we're only allowed to use outer shell electrons. So there we go. I can access another lithium, and if we look at that, I now have both lithiums. I've got full outer shells that both got electron arrangements of 2. I show that by putting a little 2 subscripted to the bottom right hand corner of my square brackets for my lithium. Okay, my oxygen is the same. Okay, I go XX. Now this is where some people will lose marks. They'll say the lithium here has lost 2 electrons, so it's 2 positive. Well, in actual fact, each lithium has only lost 1 electron, and that means that the lithiums themselves, each lithium, is actually only 1 positive. The oxygen is gained, 1 oxygen is gained 2 electrons, and it's total 2 negative. So there you go, that's how we do the lithium, and it allows us to work out the formula of lithium oxide, which will be Li2O. So I should write in the new electron arrangement of the oxygen below it, which is 2,8. That's fairly foolproof in terms of being able to get marks in an exam, guys. That's the examiner really wouldn't want any more than that. So I'll do, let's do sodium and sulfur, and you can maybe pause the video and have a go at this yourself, and I'll just pop the answer up down below. Again, we need 2 sodiums. Each sodium has lost 1 electron, so we have 2 sodiums. Each one is positive 1. And we have a sulfur, single sulfur, which has gained those 2 electrons. Becomes that. My new arrangement of sodium is 2,8. My new arrangement of my sulfur is 2,8,8. Okay, and that's how you do sodium with sulfur. Okay. Let's have a look at magnesium. okay, which is 282, with fluorine, which is 27, atomic number 12, atomic number 9. So again, we do our outer shell electrons only. Our fluorine has 7. Okay, let's show the metal is the magnesium, and it loses. But you can see now that fluorine needs 1 electron to get full outer shell, which it has now got. But the magnesium doesn't have a full outer shell. It still has this one left over. So what can we do? Well, instead of on like the last one where we had 2 metal ions, this time we can accommodate 2 non-metal ions. Okay, and that will allow us for the magnesium to get rid of both of its electrons, and for the fluorines to get full outer shell. So we'll draw our usual dot cross diagram. Should be getting pretty good at these. Just 1 cross in there. Magnesium is now 2,8. It's lost 2 electrons. And if it's lost 2 electrons, that means it's a 2 positive ion. My fluorine is now also 2,8, but there are 2 of them, remember, and each one has gained 1 electron. So the fluorines themselves, or fluorine ions as they are now, have gained 1 electron and only 1 negative. Okay, moving on. You could have a go at perhaps calcium and chlorine. Pause the video maybe. Okay, so that's 2, 8, 8, 2 and 2, 7, 17 atomic number. So Ca, 2 electrons in the outer shell. Chlorine, 7 of course. My calcium will lose because it's the metal, but that fills up my chlorine. But my calcium still has 1 electron in the outer shell. Okay, so calcium, bring it across. It's lost both these electrons and it's 2 plus. Now it has an arrangement of 2, 8, 8. My chlorine, okay, has 7 plus the one that I got from the calcium. Okay, it is now 2, 8, 8. There are 2 chlorines, remember, and each of them is -1. Okay, I'm going to do one more, really, this was probably the trickiest one of the lot, which you might want to have a go at. Pause the video and have a go, or 2 more, sorry. I'm going to do aluminium with chlorine. Okay, so aluminium is in group 3, it has 3 electrons in the outer shell. Chlorine, we've already done several times, group 7 has 7 electrons in the outer shell. So let's see what happens here. Follow the process. So I should write up here. Okay, aluminium has lost 1, so the chlorine is filled, but aluminium still has 2 electrons in its outer shell. So what am I going to do? I'm not going to do that. That's wrong. Ignore that. Okay, I need another chlorine, just like I did on the previous one with my chlorines. And I will allow that one to go to there, but that still leaves my aluminium with 1 in my outer shell. So again, I go add another chlorine. I can have as many of these as I like. My aluminium has lost its 3 from here. Chlorine has gained an electron into each one of 3 chlorines. So aluminium now, square brackets, 1 aluminium has lost 3 electrons. It's 3 plus. 3 chlorines have gained an electron each. So let's just deal with this diagram here first and then deal with that. So we put 3 there to show our 3 chlorines. They've only gained 1 electron each. So it's AlCl3. Okay, last one. Or no, you can do one like that, and then I'll do a very last one. Okay, so let's do boron and fluorine. This is not strictly speaking quite right, but it'll do for the purposes of what we're doing. So boron is 2, 3, and fluorine is 2, 7. So let's take the boron. Again, you pause the video and do this yourself, which is probably my intention here. Okay, so again, my fluorine is full, but my boron doesn't have a full outer shell yet. Remember, boron only needs 2, it's only got the first shell, it doesn't need 8, it's only got 2 in the outer shell here, so we will keep the boron. Our reminder says that the boron only needs 2 electrons in its outer shell, and we come down to there. Okay, so boron this time ends up as a 3 plus ion, and fluorine ends up with one cross in there and one, there's 7 dots. It's 1 minus, but remember there are 3 of them. And we go to electron arrangement now. 2, that's a full outer shell for boron, and 2, 8, that's a full outer shell for fluorine. Okay, right. So the trickiest one, I'll put this on the board, you can maybe have a go at it, and it's aluminium with oxygen. So I'll do it, 13 and 8, so that is 2, 8, and 7, that is 2, 6, 2, 8, 7, 2, 8, 3, I can't count. Okay, so let's put our aluminiums in, 1, 2, 3, let's put our oxygen in, 1, 2, 3, 4, 5, 6. So you'll see why this one's a bit awkward. So I can put 2 for my aluminium in, but that still leaves me 1 left over. So what do I do then? Well, if I've got 1 left over, the only place I can go is oxygen. So I simply have to put another oxygen in. So let's do that, and then let's bring that down to there. Alright, well that leaves my aluminium, alright, but I end up with an oxygen with only 7 electrons in it here. It's outer shell. I can't leave it like that. So what did we do earlier? Well, when we had a non-metal with not enough electrons in its outer shell, we brought another metal in, which we have to do. We have no choice. Okay, we just follow the same. Okay, so that leaves that oxygen fine, that aluminium's fine, but this aluminium here, the second one, okay, isn't fine. It's got 2 electrons left on its outer shell. So we have to bring in another oxygen to accommodate those 2 electrons, and there we go. My 2 aluminiums are fine, and my oxygen is also fine. So aluminium has now gone to 2, 8. It's lost 3 electrons, so it's 3 plus ion. My oxygen, as oxygen always is, has gained 2 electrons, so it's 2 minus ion. It's now 2, 8 also. Remember, there are 2 aluminiums, put the 2 down there, and 3 oxygens there. Okay, hopefully that helps you with your ionic bonding. I'll do, I suppose I'll do one more. Okay, similar to this one, then you can sort of test yourself on that. Okay, so if again you pause the video and have a go. So let's take gallium with sulfur. Okay, so gallium. Okay, I'm not going to dip too far into the other. Don't do the electron arrangement of gallium because it'll get a bit messy. Let's just accept that gallium is in group 3 and has 3 electrons in its outer shell, and sulfur is in group 6 and of course has 6 electrons in its outer shell. So gallium is the metal, loses the electrons. Sulfur, this one is now happy, it has gained, it has 8 electrons in its outer shell, but the gallium has 1 left over here, so again we need to accommodate that, and we do that by bringing in an extra non-metal. So the gallium is now happy, but the sulfur here only has 7 electrons in its outer shell, so we do exactly what we did previously. Okay, stay calm, it'll all work out, and we can put one of those into that sulfur, and that means that the sulfur now is happy. It's got 8 in its outer shell this time. Okay, what do we do now? Okay, we have a gallium here which has 2 electrons which needs to get rid of. So we bring in an additional sulfur as we have done. And there we go with the sulfur with a full outer shell, the gallium with a full outer shell. And then we do our dot cross diagram. We have 2 gallium ions, each of which have lost 3 electrons, so there's 3 positive. We have sulfur, okay, which has gained 2 electrons from each of 3 galliums, so we need 3 of those, and each of those are 2 negative. Okay, hopefully that sorts out any problems with ionic bonding.